Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about rhombus and the diagonal properties of a rhombus. The three properties that we looked at in class are that the diagonals are perpendicular to each other, that the diagonals bisect each other, and that the diagonals bisect the opposite angles of the rhombus. So let's first look at the perpendicular to each other. And in this figure, we can say that the quadrilateral ABCD is in fact a rhombus because all four sides are congruent. Then, once we establish that, then we want to say that the two diagonals of the rhombus are going to be AC and then DB. So the two diagonals of the rhombus are AC and DB. Now, what that first property is saying is that these two diagonals, they intersect each other at a 90-degree angle. It might not be exactly drawn to scale here, but what we're saying is this angle here is a 90-degree angle, which makes angle F 90 degrees all the way around here. These are all 90-degree angles. Okay? And then the second property, the diagonals bisect each other. Well, here we have the two diagonals again. What we're saying is that AF is going to be congruent to FC, and that DF is going to be congruent to FB. Now, do not make the mistake of thinking that the DF here will be congruent to the AF. That is only true in a square or in a rectangle when the diagonals are congruent. So, in the rhombus, the diagonals are bisected, which means what we've drawn here on the figure. And the third property is that the diagonals bisect the opposite angles of the rhombus. So here's what that means. We already know that angle ADC, so angle ADC, is congruent to angle ABC. We know that because that's a property of parallelograms. The opposite angles are congruent. And we also know that angle DCB, so angle DCB, is congruent to angle DAB, so angle DAB. And again, this is a property of just a parallelogram. So these two statements here are properties of parallelogram. However, the diagonals here are going to bisect those opposite angles. So what we can really say here is this, that this angle ADF is going to be congruent to FDC. And then angle ABF here is going to be congruent to FBC, this angle. And in fact, the four green angles there are all going to be congruent. So the diagonal DB is bisecting those angles. Then if we look at the other diagonal, which is AC, it is also going to bisect. So here, angle BAF, so angle BAF is going to be congruent to angle DAF. So I'll use 2 marks there because they're not the same angle as the 1 arcs. Okay? And that also means that DCF, this angle, is going to be congruent to FCB, this angle. So those are the properties. That's what the properties of a rhombus give us in the diagram. Now, in this picture, we also were given 2 pieces of information, that AF is 14 and that angle ADC is 82. So ADC would be this whole angle right here is 82 degrees. Okay? So let's, we're also asked to find 6 pieces of information. That's down here at the bottom. So let's go through these one at a time. Angle ADF, so angle ADF, which would be this angle here, what's that going to be congruent to? Well, that's going to be half of angle ADC. So it's going to be half because the diagonal is bisecting that angle. So half of 82 here would be 41 degrees. Then we're looking to find angle DCB. So angle DCB would be here. Well, we know that angle ADC plus angle DCB, when they add together, they have to be equal to 180 degrees. And the reason we know that is because this is a parallelogram, and consecutive interior angles are supplementary. So if the whole angle ADC is 82 here, then that leaves an unknown number here to equal 180, which means that DCB is going to be 98 degrees. 98 degrees. Okay? So DCB, this whole angle right here, is going to be 98 degrees. So we'll write that down. Equals 98 degrees. Another way you could look at that to find that same piece of information is you could use a right triangle trig ratio. So if we were trying to find DCB, we would say we would have to break down one of these triangles within the figure. And we know that angle F here is going to be 90 degrees. So we know this is 90. And what I've done here is I've taken triangle ABF and I pulled it out and put it down here. And again, angle F is 90 degrees. We already know that angle ADF is 41 degrees, which makes this 41 degrees, since those are congruent in the picture. And that makes this 49 degrees. Okay? And again, you can only use trig ratios when you're dealing with right triangles. And if we wanted to find the measure of DCB, well, we know that this whole thing is going to be equal to this whole thing. And since we know that this angle here is 49, and it's half of the entire angle, this is also 49 degrees. And this is 49, and this is 49. So we could just add those two up and say that's 98. I guess we didn't really use a trig ratio there, but we're using a right triangle nonetheless. We'll come back to the right triangle here. And so next is angle FCB. We've already kind of said this one, but this is 49 degrees. Now let's look at the segment lengths that we need to find. So let's start with AC. And AC is going to be it's going to be double, it's going to be double of AF. And I'm going to call AF here X. So here's where you're going to use your trig ratios. And essentially, we could use the fact that we know AF is 14. I'm sorry, we already know 14 here. So that AC is going to be double of that. So AC is going to be double of AF. So we can say that's going to be 28. And then FB, this is where our trig ratio is going to come in. Let's go ahead and call this X. You could use tangent here because you're dealing with two legs of the triangle. And you would say either tangent 49 or tangent 41. I'm going to go ahead and use tangent 49 is equal to the opposite leg, X, over 14, multiply by 14 on both sides. And you'll get X equals 16.1 for FB. So FB, 16.1. And then to find BC, well, if you notice, BC here is going to be congruent to AB. Okay, so really we just have to find the hypotenuse of this triangle on the bottom. We'll find AB here at the bottom. And we could use either sine or cosine. I'm going to use cosine. So I'm going to say cosine of 49 is the adjacent leg, so 14, over the hypotenuse. And the hypotenuse is going to be y in this case. So we're going to multiply by we're going to multiply by y on both sides. Multiply by y. And then we're going to divide by cosine 49. So y equals 14 divided by cosine 49. And then y is going to equal 21.33, which one we can substitute in for BC. Okay. So that sums up what we're doing with the rhombus. And essentially, you need to know the three properties of the rhombus, of the diagonals of a rhombus. And you need to be able to use the right triangle trig ratios to solve for the side lengths.